Hello, everybody. Welcome to another session regarding the DynamoDB especially. So actually, we'll also talk about the databases in the AWS. So it's not only about the DynamoDB. Let's wait for a couple of minutes for everyone who wants to join. But now, let me please know if you can see my screen and if you can hear me well. So yeah, as usual, there should be the presentation about this task. For now, let's have a look at the agenda. So it may be a bit more informative when just the hello screen. So, sorry. So as I already said, today we'll be talking about the databases in the AWS. So besides the usual relational databases or maybe some in-memory databases, AWS also provides us with the ability to deploy the database as a service. So it means, as usual, what AWS will take a bunch of responsibilities regarding the security updating, upgrading, and failover, auto scaling, accessibility on their shoulders. So it will be not more an our headache to upgrade in our virtual machines, install the latest database version, and so on. It will be the headache of the AWS. But sure, yeah, we may talk also about the prices, but still, who we are to talk about the prices? We're just developers. So we should just provide this information to our customers and tell them, okay, so here we go. We can just deploy this one and don't care about the overtimes and so on. So everything will be done automatically by AWS in the time which is more convenient for us and for AWS as well. So we'll talk about the types of databases in the AWS, types of services with the types of services which are provided in the databases in the AWS. Next, we will overview the DynamoDB, which is important for the task number 4. Actually, we will just deploy this database, put in some data which is necessary to make our application work, and adjust a bit in our Lambda functions just to make them integrated to the DynamoDB. Next, we will talk about the data structure in the DynamoDB because I think all of you may know what is MySQL or the PostgreSQL is. So where you need to create the tables, and these tables should have columns with some data types and so on. So yeah, and we will talk about how all of it implemented into DynamoDB. And next we will overview the hands-on task, and we will have a look what are the criteria of definition of done of this task and how should we submit it. And for sure, in the end, you'll have an option to ask the questions if you have any. Okay, let's move on and have a look at the database types in the AWS. I'm not sure if I put it all of them, but still, it may be the vast majority of the database services in the AWS. So first one is RDS, so just a relational database. What it is? So AWS provides us with an option to deploy the RDS on the managed resources. So sure, you always have an option to deploy the virtual machine, and on this virtual machine you can install the database, and you can also create another virtual machine and make a replication between them and store the data at the NFS share, for example, just to make it backed up. So it's up to you. But if you're looking for a bit more, let's say, advanced level, where you don't need to, once again, think about patching, security, and so on, you can just deploy the RDS. In this case, AWS will take a bit of responsibilities on their shoulders. So we'll think about how to upgrade and so on. We will also think about how to scale this database on your needs. So if you will go out of memory, we will just adjust the disk for you and so on. And the next option is AuroraDB, which is, I would say, the same but different. So if we are talking about the AuroraDB, AWS gives us an option to choose between MySQL and PostgreSQL databases, like an engine for this service. But in case of RDS, sure, we can choose MS SQL, and I think there is a bunch of options, but we'll try to have a look at them today. So, but in case of AuroraDB, you will not need to think about the replication between your databases and the failover. Actually, I think the same is in the case of RDS, but you will need to click some buttons just to make your database being replicated. But if you are talking about the AuroraDB, we will be just provided with the link, which is enough to connect to our database, and the rest will be on the shoulders of the AWS. So we will replicate your database. Sure, you will have an option to make backups, but in case of something is happening with this particular replica, AWS will just run the failover process, and your database will be accessible no matter what happening with the replica, which were kind of, let's say, main one. Next, we also have the Elastic Cache. So it's just managed in-memory database. So it's quite fast. So you can just, but it's quite fast key value storage. So where you can store some key, and under this key should be some value with some limited amount of memory, just to make, just to keep it fast as possible. And you can use this one, for example, if we are talking about the, I don't know, let's say something ephemeral. So, for example, you want to log your current attendance to your application, connections to your application. And in this case, this fast and managed service will be very helpful for you, because as fast as you can put data in it, the same time you can get data from it. So it's much faster than the databases which are storing the data on the disks, just because in memory, yeah, I think it should sound like this. So in memory, this memory is much faster than the one we are using on the RDD or even SSD. And next, we also have the DynamoDB. So DynamoDB is kind of AWS native database, which provides us the same key value storage. Okay, but it's actually not key value, but it's non-relational database where we can store as many columns as we want. We don't need to care about the tables, about how they look like. All we need is just to provide the name for this database and the primary key, and it will be enough to make our database work. And it's once again, it's much faster than the relational databases, just because it don't have this engine where we need to store these relations. And we will try to have a look on how this database look like a bit later today. So next, we have a bunch of very specific databases. So first one is DocumentDB. It's a place where we can store huge documents like a JSON or something like this under some keys. Sure, once again, sure, you can deploy it somewhere on your virtual machine, but it may be a bit much more convenient for you to deploy it, to get it like a service in the AWS. Next, we have a Neptune database. I actually don't know what it is, but it's something what handles the huge amount of the relations between the tables. So for me, it looks like the same relational database. I don't know, but you know, when I read the documentation about this one, we've been saying something like, okay, this database is best suits you if you are trying to create your social network. So this looks like the place where you can make relations. I don't know. And actually, I can't say much also about the second one. So it's QLDB. It's abbreviature, but I can't recall how it. Let me have a look. So QLDP. I have a note somewhere because I tried to actually remember how it looked. How should it be called? But maybe let's have a look at the second slide. At the next slide. So yeah, hopefully I provided the encryption of this letters. So actually, if you are talking about the QLDB, it's something what gives you an option to trace all of the transactions in this database, and they are immutable. So if something just did something, it always may be traced. So something like this. And in the end, we also have the time series database. So if you are talking about the IoT, so some modules or let's say, yeah, some modules, and you need to track your data depending on time. So in this, sure, you can also leverage, for example, MySQL or something like this, but a bit more convenient way is to deploy this time series database, which will also give you an option to visualize all of your data, and this data will be a bit more consistent with relation to time when just the relational database. Yeah, and on the next slide, I guess, I'm not sure if you can see something, because whenever I created this presentation, it was quite readable, but not here. Okay, but anyway, so as I already mentioned, four, let's say, main database types. So RDS, AuroraDB, Elastic Cache, and DynamoDB. And here you can see the difference between them and use cases where they may be helpful. Yeah, unfortunately there is no QLDB, so let's go ahead and Google it. So QLDB, it should be some kind of quantum ledger database. So yeah, if we are talking about some finances or something like this, so yeah, this one may be, for example, helpful for you. Okay, so let's back to our four databases which are more frequently used, a bit frequently used. So in case of RDS, AWS will manage the cross-region and multi-AZ replication for us. So it means that we will not only have the database on one virtual machine, but AWS will make it possible for us, will make the replication for us in different availability zones and even in the different regions. Actually, pretty the same is if we are talking about the AuroraDB, but as I already mentioned, in case of AuroraDB, we will be also provided with only one entry point to in our database, and all of the failover stuff will be managed by AWS. So we will just have an entry point and we will use it no matter what happening with the back end of these databases. And actually pretty the same if we are talking about the in-memory databases and DynamoDB. So AWS will manage all of the replication and the failover for us. So we'll be given just one entry point, which we will use in our applications. Okay, let's have a look at the data structure in the DynamoDB. So for one of you who is familiar with MySQL, once again, so you can create the database. In this database, you can create a table, and in this table, you need to provide the name of columns, so and the data types for each particular cell, and not cell, but column. But in case of DynamoDB, we can just create this primary key, which will be enough to fill in our database with some data. I think better than looking at this one, let's have a look on how it looks like on the AWS console. So bear with me for a second. So I'll rearrange these windows a bit. To do it a bit more convenient, I don't know. Yeah, it should be like this. Yeah. So here we go. Hope you can see, but this is my AWS console. Let's go ahead once again to the search bar and type DynamoDB. Okay, yeah, here we go. A bit lagging for some reason. What should we do next? We should just create table. We'll create this table, for example, products, yeah, right? Just because we are working with the application, which is kind of web store or something like this. So yeah, it will be in our products. And next, we need to specify the partition key. So it will be kind of primary key, but why does it call partition key? Just because we also have a sort key. It may be helpful, for example, if we are talking about I don't know. Let's imagine. Okay, let's imagine an example. So it's like if you have some video game, and in this video game you may have the game ID, and this game ID may be duplicated between some modes of this game. So the partition key will be game ID, and the sort key will be the mode of this game. So and in this case, the concatenation of these two parameters, of these two keys, will be your primary key. But since sort key is optional, so I will leave it as it is, and I'll also provide the partition key, which will be ID in my case. So you also have a bunch of data types which may be used in this partition key, but I will leave it as it is once again. So I'll leave it as a string. Should we customize it something just somehow? I don't know. But just for educational purposes, you can just open this customize setting and just have a look on what are the options in here. So can't say much about the first one. So recommended the tables to store data in access if storage at dominant table cost. Okay, let's leave it like this. So, but this is, I think, the most important thing. There are two types. So first one is on demand. So it means what this database will scale from the amount of the connections and the amount of data which are stored in our DynamoDB. But if we are talking about the provisioned, it may be sometimes a bit cheaper than the on-demand one. But you should be careful with it, just because sometimes you can just meet some thresholds and your application may just crash, or just something bad may happen just because your application may not connect to the database, because it will be a bit lagging or just something like this. Yeah, and here we have the read capacity and write capacity. We can specify them separately and so on. And I don't know where it is, but there should be an option to make in our database not publicly accessible, so like an internal one. Okay, but okay, well, what should you keep in mind? So whenever we will make in our database like an internal one, we will also need to make in our Lambda functions operatable in our VPS, in our virtual private network. Just because if we will make in our database, so where it is? Oh, it's bizarre. Okay, let's leave it as it is. Keep default, blah blah blah. Secondary indexes only by the AWS. Okay, let's keep it. Deletion protection, don't need one. Thank you. Let's just create a table. Okay, don't know where it is, but still. So yeah, you should keep in mind. But in this case, your database will be opened to the world, and everyone from the internet may get access to your database. So it's a good idea to secure it somehow, create the user, and maybe just use the IAM roles to access to your database. I think it will be the best way. So right now we are looking at our table. So we have just freshly created it, and it's called product. And what can we do? We can just go ahead and create item in it. So as you can see, in our primary key is ID. It's a string, so I'm free to write anything in here. And next, what can we do? We can just add a new attribute for this particular item. So let's be some number, and it will be called, for example, price. We will say 200. Keeping in mind dollars or whatever you want. And next, what else can we do? So we can add these attributes as many as you want. But just keep in mind that your primary key should be unique one for all of your table. And if we create the item, so we will see, but this is how our table looks like right now. But what's gonna happen if we will just add another item which will have another ID, but in case of attributes, we'll create some number, but we'll not call it price. We'll call it amount, or just let's call it stock, right? So this is how many items is in our warehouse right now. Let's do it like this. And as you can see, so now, right now we have 2 items in our database, but all of these items have different attributes. And what are the options? What options this approach gives us? So we can just use one table for all of the data which are necessary for our application. Maybe it's not the best approach, but from the perspective of the price and maybe maintenance, sometimes it will be much better just to leverage one table for all of our necessary stuff, which we can unite somehow by the needs of our application. So, since we have some time, let's have a look on how RDS looks like, and maybe let's also have a brief look at the Aurora DB. What are the options? Aurora DB. Aurora? Okay, yeah. I suppose it should be somewhere in here. So it will be actually a topic of our upcoming tasks, just because we will also need the relational database, if I recall it correctly. Let's have a look at the schedule. Backend organization, yeah, integration with SQL database. I believe we will integrate it with the RDS. Yeah, let's have a look on how it looks like. So jump into the AWS or a console and opening the RDS. We have a bunch of options with which databases we can work. So as I already mentioned, there is Aurora one, which supports the MySQL and PostgreSQL engines. And we can also create the MySQL, Postgres, Maria, and so on. In this case, it will be a bit more complicated than the DynamoDB, but still. There is also free tier, as usual, credentials, so on. So just the typical, let's say, just the typical configuration of your own database. But let's back to the RDS a bit later when we will have a dedicated lesson about this one. Now let me, I think, share back the presentation. I think the already talked about this one. Let me rearrange the screens a bit so I will look almost at you. Okay, so here we go. Data structure in DynamoDB. So as I already mentioned, the primary key is something, it's the concatenation of the partition key and soft key, and there is an attributes inside, and we can have as many attributes as we want, and items in our database don't need to have the same attributes inside one table. And now let's have a look at the task schema. So if you remember, so on the previous task, we just created the Lambda functions, and these Lambda functions will be pre-populated with the mock data. And whenever we are trying to reach our endpoints, we just got the information which is hard-coded in our Lambda functions. It's good, But right now we will try to connect these Lambda functions within our DynamoDB. It's called productsDB, yeah, but it should be DynamoDB. Maybe it's, yeah, it's probably should be DynamoDB. And in this database, we will need, during this task, we will need to create two tables. One will be for products, and the second one for the amount of these products. Yeah, for stocks, right? I think let's have a look at the task itself. So I think this schema is pretty simple. So we had Lambda functions with the mock data, but right now we should have Lambda functions which, to retrieve the data to the requester, should go to the DynamoDB and get this data. So this is how it should look like, how it should work like. And we also have a third Lambda function here, as you can see, and which is called create product. So we will need not only to get the data from the DynamoDB, but we will also need to implement the Lambda function, which will be responsible to put data in the DynamoDB. Let's have a look at the task. Once again, let me rearrange all of it. So yeah, share the screen. Here we go. Integration with NoSQL database. This is a place where you can see the architecture, the same picture that I've shown just right now. Here's the description. So you will need to go to the DynamoDB and create two tables. Sure, you can use the CDK for it, but I don't think it's the best practice. Just because if for some reason you will need to destroy something in your CDK, accidentally you may destroy your tables, and not sure it's the best practice. So in case of DynamoDB, just I think go ahead and create all of it with the by your hands. So just go to the console, create these two tables, and that's it. Write a script to fill tables with test examples. You may choose any language you want, or even you can just go to any LLM and ask, okay, create me the script to populate my DynamoDB tables with random data. Or you can just make it by yourself. It should be something dedicated and not anyhow related to the Lambda functions. It should be just a script which connects to your table and just puts some data in it using the API or maybe any library which exists for your programming language. We need it just for testing purposes, just not to put all of this data manually. We'll create the script for these purposes. Next, we'll need to extend in our AWS CDK stack with data about your database table and pass it to Lambda's environment variable section. Actually, it's pretty explanatory. So you will need to go to your CDK, find the place where you create in your Lambda functions, and create these Lambda functions and provide the secrets to this inside of your Lambda function, just to make it possible for her to access the DynamoDB with all of these credentials. And beside the credentials, it's also best practice to store the connection string and everything related to the connection to the database in the environment variables. Not to hard code it, but just to place it in some in any convenient place for you. Next, we'll need to integrate in our products list, which we've just created in the task number 3, and we'll also need to. It was get product by ID. Yeah, I think we will need to do the same. Yeah, get product by ID. And in the end, we will also need to create another new Lambda function in the same products folder. We'll also need to create another Lambda function, which will be responsible for creation of the products. So in this case, it will be not the get requests, but post requests to another application. And to handle it, we need to create the Lambda function, another Lambda function. And yeah, once again, keep in mind, but if we are talking about the API gateway, until now, we created the get endpoints, but now we will need to create the post one for the existing products endpoint. So keep it in mind. And the rest is as usual. So you just create another branch in your backend repository, or if you're using just one repository, just use it and create another branch, which should be called tasks-4. Make all the necessary changes and create the pull request to the master. It will be enough for the people who will check your job to make sure everything is in place. And don't forget to put the endpoint URLs, just to make sure, once again, just to help to the one who will check your job to get the answer on does it work or not. And sure, there is some additional tasks. They're not mandatory, as usual, but you can get additional 30 points for all of it. So first of all, in our post-products Lambda function should return error 400 status code if product data is invalid. Under invalid is if we are missing any part of the product. So for example, if we are talking about the products, yeah, so here we go. There is an ID, count, price, description, and title. Actually, count would be in the second table, so yeah. But in this case, what does it mean? So if just any of these points are missing, so you should give the 400 error. This is the idea behind this one. Next. All lambdas return error 500 status code on any error, database connection, any unhandled error in code. So yeah, I think it's pretty self-explanatory. Once again, all lambdas do console log. So if we are talking about, I believe it's TypeScript or something like this. So we are using console log, but it's not necessary in the Python. So in Python, you may choose to use just a simple print, just to make sure that all of the, let's say, debug logs are stored in the CloudFront, in the CloudWatch. So in the place where we can see the logs of the Lambda functions. And the next one is, I think, the most complicated one. So you should create the transaction-based creation of product. So by transaction-based, there is a documentation, but the idea behind of this one is, okay, so we have two tables. First one is stocks, and the second one is products. And if we are talking about the transactional approach, so you should first initialize the connection to your tables, and then let's say try to put the data in these tables. And only when you get all of the confirmations that you placed your data successfully in both of these tables, you will close this transaction. And only in this case, data will be stored in these tables. So this is transactional approach. It's a quite cool thing, and but I've never used it actually, just because never used the custom applications. All I have is some kind of native one, which I worked. But yeah, here's the documentation. It's pretty fulfilled with all of the information which is necessary to complete these 4 additional tasks. As you can see, there is a penalty, minus 50 points if you use the serverless framework. So please use the CDK for this one. And I think that's pretty it. If you have any questions, please go ahead. Okay, so let me bring the presentation back and rearrange the windows once again. So post products, this is our new create product function. Yeah, exactly. So it will be in our new Lambda function, which we'll need to create, but to point this Lambda function to the existing endpoint of our API gateway. But in this case, it should be post, but not get. Okay, any more questions? Right now I'm trying to open the information about the upcoming workshop. So yeah, here we go. It will be serverless patterns. So if you don't have any more questions, so I'd like to announce the upcoming workshop. So on the March 5th, we will have the workshop regarding the serverless pattern. So if some of you maybe know knowledge about what workshop is, but actually workshop is the place where AWS provides us with some amount of the accounts for the AWS. And with these accounts, we can go through the workshop and we will be guided by and our specialists from the EPAM as well. And we'll tell you how to do particular things. I don't know if we already have the link to this workshop. Yeah, sure we have. So I will share it with you right now. But okay, let's do it like this. I'll make an announcement in the Discord about the upcoming workshop, and I will also share the link to all of the data related to this workshop. So yeah, it will be the place where you can get the account from the AWS and just try some maybe a bit more advanced things in the AWS. And sometimes these things may be a bit costly doing on your own account. But if we are talking about the workshops, yeah, since you will be provided with the account, it will be free for you, free of charge for you. And yeah, as I already mentioned, we will be, my colleague Ivan will be talking about the serverless patterns in the AWS. So yeah, it's mostly related to our topic. Just because don't know if we have. Okay, yeah, let's have a look at this one once again. So as you mentioned, as you may recall, so all of the resources which we are deploying right now in the AWS are serverless. So it means that we don't have any virtual machines under the hood of all of the servers. So yeah, actually we have, but it's not in our but they're not under in our management. So it's just under the management of the AWS. And from task to task, we will still leverage the serverless patterns. So we will also deploy some more Lambda functions, some authentication, some and the rest of the services, which will be serverless. Have you got about additional task with logs? For Python, they should only stream all logs in debug mode to CloudWatch, correct? Not really. So yeah, I'm sorry, I maybe misspelled it a bit. So you should just put some prints in your Lambda function. I think that's it. So it will be enough for you just to place some logs in the CloudWatch. So yeah, don't spend much time on it. So just make your Lambda function as verbose as possible. So that's pretty. I don't know what is it. Is it hard to make it on the TypeScript, for example? So I just don't know why we created this special task for this one. So yeah, maybe it's not a bad idea to get rid of it. Any more questions? One, two, three. Don't think so. Okay, so if you will have any, as usual, you know where to find me. So Discord is the place where you can seek for help and ask any questions which bothers you. I believe today is the last day of the cross-check. So yeah, if you still didn't check someone's job, so please go ahead and do it. Just because you need to check all for submissions which are assigned to you, just to get your own points. Okay. Okay, one more question regarding cross-check. What happens if we have been checked by only one person? So you will always have the arithmetic mean of some of the points which were given to you. So in this case, if it's just one person, so you will get the amount of points divided by 1, and this will be your points. So in this case, just the exact amount. So yeah, it's not a big deal if you get not all of the points. It's a problem where you don't give points to just someone in the pool which were assigned to you. Okay, so hopefully see you on the next week. Good luck, and if you will have any questions, feel free to ask them. Don't hesitate. I'm in the Discord as much as possible. So yeah, see ya. Bye.